Good morning. Today we'll discuss the numerical problems on differential protection of busbars. So far, we have seen the differential protection of busbars, why it is generally employed. Normally, in busbars, we do experience internal faults and also external faults, but the differential protection is employed exclusively for detecting internal faults. Most of the times, your bus bars are represented in this fashion, where there will be too many number of incoming and also outgoing feeders. So your bus bar is just like a meeting point for so many number of wires. These wires are technically called as feeders, and here they are connected to your bus bar. And CTs, what we call it as current transformers, are provided at regular intervals in order to measure the current which is flowing in your feeders. And the summation of all these CT currents is the current of your feeder. Current of your bus bar. If you see this particular figure, you are having two incoming feeders whereas two outgoing feeders. The summation of CT currents of these two is equal to your total incoming current of your feeder, whereas the summation of the currents of these two is called as the outgoing current of your feeder. Now, if I am designing a differential relay for this bus bar, my incoming current is the summation of these two currents. So I'll join these two in parallel, and the resultant current here also on the this is my differential relay. So the currents, one current here I'll be placing this is the way how incoming current flows, and this is the way how my outgoing current flows. If you see effectively what is the current which is flowing in this relay, ideal case it will be equal to 0. Incoming current is equal to outgoing current. Here I will be placing an overcurrent relay which will detect the currents, incoming current and outgoing current, and the difference, literally the difference between incoming current and outgoing current. So delta I is observed in your overcurrent relay. Normally, this overcurrent relay will be adjusted to have a pickup value. This is done in order to overcome any stray resistances or any saturations which are available in your circuit. A minimum of normally 0.5 amperes or 1 ampere is generally provided as a pickup value for your overcurrent relay. So if the difference between your incoming and outgoing currents is greater than this pickup value, then your relay will be operating. And in particularly, to overcome the problem of CT saturation, we have seen that a high impedance is connected in series with your overcurrent relay, and we call it as stabilizing resistance. We call it as ZS, and it is generally stabilizing resistance. And this stabilizing resistance helps us in overcoming the problem of CT saturation, because normally what happens is during external faults the current may be very large enough to push your CTs into saturation. And if any of the CTs move into saturation, then there may be a spill current flowing in the circuit, which may result in unwanted detection of your faults. So now, in this lecture, we will see what is the maximum safe current, safe external fault current, which can be allowed in your differential relay, or which can be carried out by your bus bar, such that it doesn't get detected by your differential relay. And also, because of the high impedance which is present in this overcurrent relay, there is a very high probability that sometimes internal faults are also not detected by a relay. So, in today's class, we will try to determine what is a maximum fault current, maximum external fault current, for which your bus bar remains stable and thermally stable also, and the minimum fault current which can be detected by a differential protection scheme. And the ratio of these two is called as a stability ratio. That also we'll try to determine today. So before moving on to the problems on this one, let us try to note down some important formula. As already said, a bus bar will be having too many number of feeders. When you do have too many number of feeders, each feeder may be carrying different amount of current, and the CTs also generally they will be varying. But for an ideal case, should maintain a common CT ratio for all the CTs. And I have said in the last week lectures itself that the CT ratio for all CTs must be equal to the maximum of all the feeder currents is to 1. This is one of the important things which you are supposed to remember. CT ratio for all CTs is equal to maximum of all feeder currents is to 1. Okay. The second equation is regarding your stabilizing resistance. As already said, your relay is supposed to have some voltage setting. Defaultly it will be having a voltage setting and also pickup value. These two are adjustable by a differential scheme. Try to remember. One is a voltage setting, the other one is a pickup current. These can be adjusted by a differential. So every time you want to change the settings, you will be adjusting these two. One is a voltage setting, the other one is a pickup current setting. As already said, if you see the differential scheme, there was a high impedance and there was also a relay, right? This was one current which was flowing, this was the other current. If you carefully see, this is a voltage setting. Right. So what is voltage setting? So what is the current which will be flowing in this one? The minimum current which your relay will detect is nothing but your pickup current. So V set is equal to I pickup current into, this is R stabilizing resistance, right? And this is your R relay. So R stabilizing resistance plus R relay. So if I rewrite this equation, R stabilizing plus R OC relay is equal to V set plus I pickup value. This you should remember. This is the worst case. Normally your stabilizing resistance is selected such that it is very greater when compared to your V set by I pickup. Okay. And the next thing is regarding the external fault currents. We have seen in the last lectures itself that this is the formula. V set is equal to IF external max into ZS by N, where ZS is nothing but a secondary side resistance. Secondary side impedance, where N is nothing but here an IF external max. This is the thing which you will be calculating all the time. Okay. And coming to the internal faults, which is the minimum value of the internal fault which you need to detect, is given by N into IPU plus small n into I. This is your pickup value of the power current relay, and this is your number of feeders, both incoming and outgoing combined, and this is your leakage current, and this is your transformation ratio, CT ratio. then the ratio of the external maximum fault current and the minimum internal fault current which will be detected is called as the stability ratio. And finally, regarding the supervisory relay, which is generally employed when there is an opening of the pilot bars. We have seen that we will be using an overvoltage relay also, right? So what is the voltage setting of your supervisory relay? And this is the formula. High load maximum load current which you are trying to allow by N into R stabilizing plus R OCT. So these are the 6 formulae which you will be employing in your unit number 3 problems. And now we will be trying to solve problems on this particular differential protection of busbars.